Let us see today the first unit, partial differential equations from transforms and partial differential equations paper, which is third semester paper of regulation 2021. Okay, so partial differential equations. So first let us see the difference between ordinary differentiation and partial differentiation. Ordinary differentiation and partial differentiation. We shall see the difference. So here let us listen here. Z is equal to f of x. Z is function of one variable. Here you take Z is function of two variables x and y, right? It need not be two variables, it can be more than that. X, y, r, s, t. Okay. So when Z is function of one variable, right? Ordinary differentiation comes. When Z is function of more than one variable, partial differentiation comes. So here you can see example, Z is equal to x square, right? So x can take any value, but Z depends on x. When x is 2, Z is 4. When x is 3, Z is 9. So Z depends on x and x is independent. So x is independent. X is independent and Z depends on x, so dependent. Similarly here Z is function of x and y. So x and y are independent variables. Let us take Z is equal to x square plus 4x square y plus 3xy cube plus y square. Z is function of x and y. X and y can take any values, they are independent. But Z depends on x and y. Hence Z is dependent. Z is dependent. X and y are independent. Okay. So now it is very clear. When the independent variable is only one, it is ordinary differentiation. When the independent variables are more than one, partial differentiation. Okay. We have partial differentiation when the number of independent variable is more than one. Okay. Here when you differentiate, it is dz by dx, right? Here when you do differentiation, we do dou z by dou x. Because, listen here, we have two independent variables. When you differentiate with respect to x, y becomes constant. So keeping y constant, differentiate with respect to x, which is partial differentiation. Differentiate z with respect to x partially. The word partially is for keeping other variables constant. Okay. So it replaces many words. See, partially replaces many words. Keeping other variables constant. When you take z is function of xy, when you differentiate z with respect to x partially, y become constant. That's why partially the word. Okay. Dou z by dou x. Let us take this example. Z equal to x square plus 4x square y plus 3xy cube plus y square. Z is function of x and y. Let us find dou z by dou x. Y is constant, keep in mind. So this x square becomes 2x. Y is constant, take out 4y. Take 4y out. Differentiate x square, which is 2x. 4y into 2x is 8xy. Similarly, take y cube outside. Differentiate x, which becomes 1. So 3y cube. Differentiating y square, being y square constant, when you differentiate it will become 0. Okay. Let us do dou z by dou y. Differentiation of x square becomes 0 because x square is constant. When we differentiate with respect to y partially, this x square is constant. So it will become 0. When you differentiate it with respect to y, take 4x square outside. Differentiate y. Y with respect to y is 1. Why do we take 4x square outside? Being constant, right? So take 4x square outside. Y with respect to y is 1. Similarly, when you differentiate with respect to y, 3x is constant, take outside. Differentiate y cube, which is 3y square. So 3x into 3y square, which is 9xy square. After reducing power, you differentiate y, right? When you differentiate y cube, it is 3y square. Again differentiate y, which will become 1. Okay? Differentiating y square, which is 2y. Then differentiate y, which will become 1. Okay? First you reduce power, then you differentiate the term. Okay? So it's very clear, listen here, when z is function of x and y, these two are also, the derivatives are also functions of x and y. Not only these two, even second order derivatives, right? Third order derivatives are also functions of x and y. When z is function of x and y, the derivatives are also functions of x and y. Okay? So what we do is, listen here, we think ourselves is, seeing dou z by dou x, we assume ourselves it is function of x. No. When z is function of x and y, the partial derivatives are also functions of x and y. Dou z by dou x is function of x and y. So this can be differentiated again with respect to x as well as with respect to y. Okay? Dou z by dou x can be differentiated with respect to y. Okay? So it should be very clear. It should be very clear. Okay? So when z is function of x and y, the derivatives are also functions of x and y. Okay? So I hope you have understood the difference between partial differentiation and ordinary differentiation. When the number of independent variable is only 1, it is ordinary differentiation. When the number of independent variables are more than 1, it is partial differentiation. Okay? So you know, here we write dz by dx. Here we use partial derivatives. Partial derivatives. Okay? So this is what we should know. And it is equation. Partial differential equation. You know equation. Any polynomial equated to 0 is equation. Any polynomial equated to 0 is equation. Here it is partial differential equation. Listen here, we will have dou cube z by dou x cube plus 3 into dou square z by dou x square plus 2 into dou square z by dou x dou y equal to some 0. Equal to 0, which is partial differential equation. So equation which contains partial derivatives. An equation which contains partial derivatives, which we say partial differential equations. We know what is equation. Any polynomial equated to 0 is equation. In equation, if we have partial derivatives, it is partial differential equation. Okay. And you should know, throughout the unit, what we consider is z is function of only two variables. Though z can be function of any number of variables here in partial differentiation, in first unit, we assume throughout the unit z is function of only two variables. Anyhow, it is more than one. So, it is more than one. So, what we say, it is partial differentiation. Okay. Partial derivatives comes. Okay. And listen here, we use some standard notations. See, when you differentiate z with respect to y, we use notation p. When we differentiate with respect to y, it is q. When we differentiate this dou z by dou x again with respect to x, what is the meaning? Dou z by dou x with respect to x. Dou by dou x of dou z by dou x. When you differentiate z with respect to x again, which is dou square z by dou x square, which we call as r. Similarly, when you differentiate this dou z by dou y with respect to y, dou z by dou y with respect to y, which becomes dou square z by dou y square, which we call as t. Okay. And you have already studied, right, in school, dou square z by dou x dou y is equal to dou square z by dou y dou x. Listen here, what is the meaning? Dou by dou x of dou z by dou y. which is dou by dou y of dou z by dou x. See, when you differentiate dou z by dou x with respect to y, or when you differentiate dou z by dou y with respect to x, answers will be same. Okay. And you know this can be differentiated with respect to y, right? Since z is function of xy, the derivatives are also functions of x and y. So it can be differentiated with respect to y. It can be differentiated with respect to x. And the answers will be same. Dou square z by dou x dou y. Dou square z by dou y dou x. Answers will be equal. Okay. Answers will be equal. And we call it as yes. Yes. This dou any you can use notation yes. S is equal to either dou square z by dou x dou y or dou square z by dou y dou x. Okay. Okay. I hope you have understood the notations P, Q or S, T. Right. So you know difference between ordinary differentiation and partial differentiation, and what is partial differential equation, and what are the standard notations. Okay. So the thing what it should be clear is, when we have more than one independent variable, partial derivatives occurs, and in an equation when partial differentiation derivatives comes, it becomes partial differential equation, and the standard notations with these two are equal. You can differentiate this with respect to x or this with respect to y. Answers are going to be same, and we use the notation for it as yes. Okay, yes, s equal to. Okay, so I hope you have understood. So in the next video we shall start. In the next video we shall start the formation of PDE. Okay, thank you.